All right, so any questions? Everybody got high-low done?
Yes.
Let's do tomorrow. You what?
I need to submit it.
You need to submit it. Yes, you do. And submit it early and often. What ODP are we up to? I don't even know anymore. 18, good, thanks. So here's some code for 417. Pair pointers, input location and output location. Usual for loop input location goes from 0, I include up through string length so that I pick up the null terminator automatically, which I know won't be an X, so it should get copied. And there's a flag, that's my whole notion of state. There's a done flag which says that if I already removed one X, so that starts off at 0. And then for each character in my input string, if it's not equal to X, or if I've already removed the first X, then I copy from the input location to the output location and increment the output location. If the input location is equal to X, I go ahead and I set my flag so that I'll know that I've seen one X. And going up to string length copies the null terminator at the end. Tons of different ways to do this, right? But that's one way to get there. So 418, today's ODP, so we are moving the first character of a string to the end of the string. Yes?
Sorry, this is still my question.
Yeah.
I haven't checked, but do you put what the code that you write for the ODPs at?
No,
There you go.
no. But you should have a working copy. Did you get 10 out of 10?
Yeah, I
Okay,
got it. I just
so you got a
wrote
working
it
copy.
differently than
Yeah,
I did.
yeah.
I didn't know if there's a way to look at that.
I'm not really posting them, but I mean, I can put it back up there. Just want to do a picture. I'll probably use these same ODPs next year, so I don't want to like put them somewhere general on the web.
Okay.
All right, so 418, you're taking a string and you're moving the first character to the end. So if your string is A, B, C, D, E, it should get turned into B, C, D, E, A. And one caveat, when you're testing this, if you're testing this and you're using fgets, and you say hello, enter, your string is actually HELLO with a new line. That should get changed into ELLO new line H. So that'll look weird, but that's perfectly correct. Okay? But the easiest way to test this is just to hardwire some strings and make sure that they're coming out correct. Or chop off the new line after fgets, or leave the new line there and just make sure it's doing the right thing, which looks like the wrong thing, but it's right. So yeah, the rest is boilerplate. 2 strings. First one's the thing that you're processing. The second one is where the output is placed. You can use string length. And there's a test bed. ODP 418 main.o. And assess it like that. So any questions with this? Got a good idea how to do this? So again, you don't really need a pair of pointers here, right? You're really just kind of taking each character and moving it down one spot. And then your first character gets set up to come from the end of the string and do something to put a null terminator on the end. And here you can't just shove the null terminator down. You're going to have to explicitly put it in somewhere. but just cobble together the string. So the point of these last few ODPs is just to get you kind of more hands-on with strings as sequences of characters, right? As arrays of characters, and getting you comfortable with manipulating these things, right? And really all you're doing is manipulating an array of data, right? But in ways that need you to keep track of state or keep track of input versus output and so on. I don't even know what 419 is. Yeah, we're not going to worry about that. All right, so this will be your last ODP for the week. I won't give you one tomorrow. So any questions on these things we were playing with yesterday? Any of these that you want to talk about? Or should I assume that you know how to do all of these? So, all right, I'll talk about one anyway. So like adding an S to the end of a line that begins with a T, right? The whole thing with regular expressions is you're doing searches and then replacements, right? So if you want to add an S to the end of a line that begins with a T, first thing you have to do is detect a line that begins with a T. And we can do that by saying beginning of line T. And then we want to add an S to the end of it. And there's no way over here we can just say put an S at the end. What we can do is we can say take everything up to the end and replace that with everything up to the end followed by an S. Right? We can take things that we've matched and put those in our substitution. So if our match pattern is more than just this, if we say start with the beginning of the line, find a T, find any succession of characters, and then find the end of the line, we could replace that with the same thing followed by an S. And so to do that, we want to take this and throw it in a register, and then replace it with the contents of that register, followed by an S in this case. And it doesn't matter if these parentheses include the $sign and the caret or not. They're not actually characters, they're anchors. They're saying where in the string we can have the following or the preceding pattern. But does this make sense, right? This matches any line that starts with a T, basically. If it doesn't start with a T, it won't match, so it won't do any substitution. If it does start with a T, it'll take the entire line, put it in R1, get rid of that, and in its place, put the entire line followed by an S. All right, so let's talk about some more I/O. And I've posted your PA4 already, which we'll talk about in detail tomorrow. But it's going to involve doing string processing, not surprisingly, right? Breaking things apart and putting them together in certain ways. But let's talk about input in particular. So we keep using fgets, right, to read an entire line. So if you look at the manual page, fgets is bundled together with a bunch of other things. fgetc, getcar, getc. They're all in standard I/O. So fgets reads in at most one line, less than size characters from usually standard in, stores them in a buffer. Reading stops at the end of the file or a new line, or if the buffer is filled up. If you don't want to read an entire line though, right, if you're trying to do something more sort of nuanced and you want to read a single character at a time, you can use getcar or getc or fgetc. And they're all kind of the same. All right, so test code. Infinite loop, I'm going to call getcar. I'm going to take the return value from getcar, put that in I, which is an integer. I'm going to print out the value of I, and we're just going to loop forever. Yeah?
Standard IO.agents.
It is. Thank you.
So the FPS includes the no character, the no terminator.
So it will not include, we're not reading strings, we're just reading input from standard in this case. So there's no null terminators, but there will be new lines. Okay. And the first thing to wonder about maybe is why we're returning an integer instead of a character, because it's called getCharacter, right? Why are we returning an int instead of a character? Well, the short explanation is because it tells us that getCar returns an int. But let's take a look at what this thing actually does. So if I say get and I hit hello, it prints out HELLO's ASCII codes followed by a 10. 10 is your new line. Okay, if I say 1, 2, 3, it gives me a 49, 50, and a 51, and a new line. And it's printing out a bunch of stuff when I hit enter, right? It's not printing anything when I hit a letter A. It's not hitting anything when I type a B or a C. But when I hit enter, it's going to go through that loop 3 times. Right? So what's happening is what I'm typing here is going into one end of this buffer, this pipeline that we call standard in. Well, it's going somewhere else first. When I hit enter, everything that I've typed gets shoved into this pipeline called standard in. And standard in has this A and this B and this C and this new line sitting here. And my program is saying I equals getCar. Right? My program's running, right? It's sitting inside this call to getCar waiting for something to happen that tells it there's a character inside this pipeline called standard in. So once I hit enter and these 4 things go in the pipe, now this call to getCar will return, and it'll return with the ASCII code of A, and that A comes out of the pipe. And the code goes back to the top of the while loop, calls getCar, and getCar looks and it sees there's a B sitting in there. So it returns right away with the ASCII code for B, and it does that 2 more times. And now my program is going to be sitting inside getCar again, waiting for more stuff to appear in here. So I hit enter and I went through my loop 4 times. All right, so if I want to signify that I'm done putting an input, do you remember how to do that from standard in?
Control D.
Control D. And it's got to be the first thing you type on the line. So I'm going to hold down Control and hit D. And I came back with a value of -1. Okay. Now Control D is not equal to -1. Control D is actually ASCII character 4. Okay, A, B, C, D. But when getChar reads from standard in and sees ASCII character 4, and it's at the beginning of a line, it interprets it as saying that's the end of the input, and it returns this flag, which is -1. -1 is not a valid ASCII code. Okay, ASCII codes are only 8 bits, and they go from 00 to hex FF, 255, actually 127. And so when we see this -1 from getChar, there's no chance that that's actually the character that was read from standard in. We can, without doubt, interpret this as a flag saying we've hit the end of the input. Right? Even if it's not the end of the input. Because we can push more things into standard in, and the next time we call getChar, it gives us the ASCII codes for those things that are inside the pipeline. But if we hit Control D, it'll send us a -1, and it's asking us to understand, hey, this stream standard in has signified end of input, end of file. So typically what you would do is something like this. So we can call getChar inside our while statement. We can take its value and store that in I, and we can use that in this conditional statement for the while, which is while -1 is not equal to that value. And then when we exit the while loop, we can print a nice statement saying we've detected, or if we detected the end of the file. So we can say hello, we can say 1, 2, 3, and now if I hit Control D, it just tells me end of file detected. Bless you. So here's a file named data. It has 2 lines, hello, and 1, 2, 3. And remember, I can redirect input using this less than sign, which says I want to run the program named get, but I want its standard in to come from this file instead of from my keyboard. So this is going to open the file, bash will open the file, read the contents of it, and pretend that that's what's going into standard in. Right, so it'll act as if I typed hello, enter, 1, 2, 3, enter, and it does exactly the same thing. ASCII codes for hello, new line character 10, ASCII codes for 1, 2, 3, new line character, and then it detects end of file. If I do this, but I send input from dev null, which is an empty file that always exists, right, it comes back right away and says end of file. So dev null is just this bit bucket. You can write to it and your output disappears. You can read from it and there's nothing in there. And it's on every Unix system. So does that make sense?
If you have not changed the while loop to check -1,
Mm-hmm.
and then you would pipe in the data, what would happen?
That's a good question. So let's just hobble that. So from here it's doing the same thing as usual, so let's try that. Alright, so it reads from the file and it gets -1 because it's at the end of the file. But if we try to read again, it comes back with another -1. So it's kind of like hitting Control D every time it asks you for input.
Is there a way to get back to normal standard to ask for more user input?
Yeah, but it's not easy. We can manipulate, so standard in and this is kind of a bit where we're going shortly. So standard in, standard out, standard error are always available to us, right? Internally, this is actually file pointers 0, 1, and 2. And when you redirect from a file, file pointer 0 is basically hooked up to that file. From a C program, we can change what file pointer 0 is, and we can reconnect it to standard in. But it takes a little bit of finagling. But it is doable. You could also open a file /dev/tty, and that's your keyboard display. So if I send something to dev tty, it shows up on my display. And if I read from dev tty, it reads from standard in, from my keyboard. So that's another way to get access to keyboard and display. All right, so okay with getcar. Again, man pages always have good information on this stuff. Getcar is like getC, and getC is like fgetC. And fgetC reads one character from a stream and returns an integer, or EOF. So try to avoid magic numbers. So the correct way to look for the end of the file when you use getcar is to see if it returned EOF. Right, and inside standard.io.h, there's a statement that says define EOF to be -1. So when you say, is this thing equal to EOF, you're really just saying it's equal to -1. But if you wake up on another planet and they use -2 for EOF, right? If you embedded -1 in your code's not going to work. If you used EOF, you just recompile and it'll work fine. So that's the main reason for using EOF. Alien abduction. All right, so in PA4, you're going to be processing input from standard in, but you're going to want to process it at a finer granularity than line by line. You're really going to want to process it character by character. And so you're going to want to make use of something like getcar. So what does it take to make something like fgets? Something that reads an entire line of input. Would that be hard to do?
You would need an array for fgets.
Mm-hmm.
It would probably operate under the similar function and the getcar.
Mm-hmm.
And it would scan every character
Okay.
into an array.
Okay. Let's just do this from standard in. So what does fgets do? It starts reading from standard in, and it starts storing each character that it reads into this string, right? Until one of two things happen. It finds a new line, in which case it stores a new line and then it's done. Or it's used up the entire array storing stuff, in which case it stops reading characters. So read one character, store in whatever the next position is in your output array. If your character is a new line, add a null terminator and return. If you've stored, well, remember, we always need to have a null terminator. So if you ask fgets to read 120 characters, it'll only store 119 in your array because it's going to save one spot for a null terminator. So if you've stored maxlen -1 characters, add a null terminator and return. Otherwise, just keep looping. And it's really not that big a function to write. Right, but it's a really convenient function because usually we just want to read in a line of text and then we want to do some processing on it and then read another line, do some processing. And if all you're reading is a single character at a time, you've got to do this, right? You've got to read until you get to the new line and keep storing in an array. So fgets is just kind of a convenience function, right? But this again is the idea of sort of modular design. So instead of writing this every time we want to read a line, we make a function and we bundle it inside. All right, so let's talk about some other file things. So we can read from standard in using getcar. And we can use fgets. So let's change this get function to read lines using fgets, our usual input method. So this is a test by, and then if I hit a control D, it detects an end of file. Right, and so fgets returns a null when it finds end of file instead of EOF. And so we check the return from fgets, and if it's null, we know that it hit the end of the input. So if I run get and I redirect input from a file, right, it reads from that file. But let's talk about this third argument to fgets. Okay, this is standard in. Standard in is always set up for us. It's a symbol for our keyboard, basically, or if we're redirecting with a pipe or a less than sign, it's a symbol for that redirected stream. But there's other things we can fget from, right? We can fget from any file that we want. So there's a few functions we need. We need fopen, fgets we already know, and fclose. So fopen we can use if we want to create a new stream that we can read from or write to, typically coming from a file. So we can say fopen, put in a file name as a string, and if we want to read from this, we put in an argument which is a string containing the single letter R. And this returns some information into a variable whose type is uppercase file. and it's a pointer to that. So if we say FP is a pointer to this file object, and then we set FP equal to the result from fopen, FP is now an input stream. And when we say fgets, we can say string length, and this third argument can be FP. And now instead of reading from standard in, we're reading from this file. So it's kind of like doing that less than redirection that we do when we run a program, but we're doing this inside the code itself. So if you always want to read from a particular file, right, this is how you can set it up. So FP equals fopen, data is the name of my file, right? So that's my 2-line file. And then I'm going to call fgets, and instead of reading from standard in, I'm going to read from FP. I'm going to print out the string, and then when I'm done, I'm just going to say end of file detected. So now I run my program, I'm not redirecting standard in, it's not going to use standard in at all. It's just going to read from that file. And if we want it to read from itself, we can just read from get.c. Right, and there's what it read. Its own source code. So if I try to read from a file that doesn't exist, what's it going to do? Basically cry. So let's take a look at this FP. I'm printing it in hex just because hex looks cooler than decimal. So let's just print out the value of FP as a hex number. It's going to complain when I compile this because I've said FP is a pointer to something and I'm trying to print it out as if it were an integer. But that's okay, it can complain, but it'll still do it. And let's make this something reasonable. So when I run this, FP was equal to this kind of nominal looking hex number. If I run this again, let's put this through more so I don't have to scroll. It's equal to a different hex number. Right, 4EF92260. If I run it again, it's equal to a different hex number. But all these hex numbers have one thing in common. Which is that they're not 0. And when I have a bad file, that file pointer comes back as a 0. And it actually comes back as null. And I can never remember if it's uppercase or lowercase. But it'll actually come back as null. Okay, so when you use FP, when you use fopen to open a file, it returns a file pointer. See if that pointer is null. And if it is, you can say error opening a file. And we can return an error code. Let's go ahead and print it here. Right. right? So if I run it with a bad file name, it'll say error opening file. If I run it with a good file name, it goes ahead and it does its thing. So let's make this a little more useful. Instead of hardwiring a file name in here, let's put the file name as a command line argument. So let's just read from argv bracket 1. And this is dangerous because I didn't check argc. So if I don't put in an argument, this will segfault. That's okay with me today. So I'm going to take whatever the first argument is. I'm going to open that with fopen for reading. I'm going to print its file pointer, and if that file pointer is null, I'll say error opening file, and I'll go ahead and name the file. And I'll exit. Otherwise, we'll open the file, and let's just print out that string. So if I say get data, it shows me my file pointer, shows me the contents. If I say get.c, and I've got this new line that I'm printing out in here. I don't really need that because when I read a new line from the file, it's already going to be in my string. And let's get rid of this, and let's get rid of this. So what have I just written? Cat. This is the cat function, the cat program. Right? Give it a file name, it opens up the file, reads the contents, prints it out, and it exits. So all these things are just functions, right? All the stuff that we use in Unix, they're just programs, and programs are really just functions called main that you can pass arguments to. The main function, you pass an argument by putting it on the command line. And the only thing missing here that stops it from being real cat is that if you just say get, you get an error message. Whereas if you say cat, it reads from standard in and echoes. But we could add that to this if we wanted to for some reason. We could check argc, and if argc was equal to 1, meaning there was no command line argument, then instead of opening argv bracket 1, we could just read from standard in. The other thing cat does is you can list multiple files. So you can say cat file 1, file 2, file 3, and it'll read from each of those in succession and print it out. And this is only reading from the first command line argument, but we could throw this in a loop, right? And for each command line argument, we could repeat this, opening the appropriate file for each command line argument, and then just iterating on those. All right, so we didn't talk about fclose. So when you open a file, you're asking to read the contents of something typically on disk, right? And on some operating systems that we won't name, when you open a file for access, you lock other things out from being able to use that file. And so if we opened a file and we started reading from it and our program never exited, it's possible that other things that tried to read that file wouldn't be able to. So there's one more statement, which is fclose, which basically undoes the open. It says, okay, I'm done using this file. So we call fclose, pass it the file pointer, and then it makes the file available for other things to use. And that's a little important for reading, but it's really important for writing. So let's look at output. So when I open my file with fopen, instead of putting an R as that second argument for reading, I can put a W for writing. And now I'm creating a file that I want to put stuff into. And FP is a file pointer for doing that. And you know how to do printf. There's also an fprintf. And it works exactly like printf, except it takes one additional argument in the beginning, which is a file pointer. And then the rest of the arguments look exactly the same. So I can do something like this. Alright, so I'll just open up new data, I'll print out a hello message, I'll print out some integers, I'll say goodbye. And then I'll go ahead and exit there. Wow, it really doesn't like me, does it? What the heck is all of this stuff?
I dropped the file pointer in the loop.
Sure enough. Thank you. Alright. Alright, so there's no file named new data in here right now. If I run put, I've got a file called new data. If I look at its contents, it's got exactly what I tried to print into there. Let's throw a sleep statement at the end here. That's probably okay. All right. So our program is run and it's executing the sleep statement, which should sleep for a while. So there's my new data. But it's got nothing in it. Now I clearly told it to print these things, and then I said go to sleep for a while. But my file is empty. Right, its size is 0. So if I kill this program, and then I come over here, my file's empty. So what's the problem here? The problem, again, it's a feature, not a problem. The problem is that when we print things to a file, printing is a buffered operation. Okay, it's very expensive to actually go to a spinning disk and plop down ones and zeros. Okay, trying to do that to write a single character takes milliseconds. Right, which means that if I spent a millisecond to write each of these characters, I'd be taking a pretty noticeable chunk of time. If I wanted to write a few thousand characters It might take a few seconds. So when you print into a file, it doesn't go immediately into the file on the hard drive. It gets buffered up, right? And when I get to the sleep statement, all of that stuff that I tried to write is sitting in some internal buffer, ready to get shoved out to the hard drive. And if that sleep statement finishes and then I hit the end of my program, before my program exits, it will do things to force that stuff out of the buffer and onto the disk. But if I just Control-C to interrupt my program, the stuff I wrote is basically lost. So if we want stuff to get written right away, we can use an F-flush. And that forces it to flush the output to the buffer. So our new data is empty. Compile this up, run it, and as soon as we run it, our output appears in our output file, even though our program is still running. Right, this stuff appeared as soon as that F-flush got executed. And now if I kill this, no harm done. I just killed a sleep statement, but the data was already written. I could also have just done an F-close. And when you close a file, that flushes everything out also.
So what will F-flush do?
F-flush lets you force stuff out of the buffer without having to close the file. So if you want to keep the file open so you can write more stuff later, but you still want what you've written so far to actually go into the file, you can say F-flush. All right, so let's leave it there for now. So tomorrow we will talk about PA4 and all the glory that goes along with that.